So I let the first class decide. They were debating this morning. They wanted a quiz tomorrow.
Why?
I don't know, because they wanted a quiz tomorrow.
No.
I thought we were supposed to have a test tomorrow.
No, that's next Tuesday.
Well, that's next Tuesday, that's right. Oh, I'm down for a place, yeah.
Why were we
Yeah,
doing
great.
this tomorrow when we already had one yesterday?
No, not a formative. Summit.
I thought we already had it.
No.
I'm down.
They decided instead they wanted a work day to go over homework. The blue homework packet.
When can we do that Friday?
What?
When can we do that Friday?
That is tomorrow.
It is?
Yeah. It's Wednesday.
See, today's Thursday, which makes tomorrow.
Saturday.
Monday, then we'll hardcore review. Tuesday, we will take a test. Wednesday, no formative. Thursday, extra credit in class if you're here. If you're not here, you lose. You don't get to do the extra credit. Okay?
So tomorrow we're working on that homework.
Tomorrow we'll work on the blue, we'll answer questions on the blue homework packet, yes. Okay? So, this one. Factor out an x. So then that leaves me with f of x here is equal to x times x minus 3 times x plus 3 all over x minus 2, x plus 2. Yes, that gives me a domain of which gives me vertical asymptotes of
X equals -2 and x equals 2.
degree of the top. Oops, let's put those on there first. Tap the brakes. Degree of the top, 3. Degree of the bottom, 2. That's top is greater than the bottom. So that is a horizontal asymptote of none case, right? But differs by 1, right? So that means I have a slant asymptote.
So if there's not a horizontal asymptote, can you have it where there's no slant asymptote too?
Different by 2.
Or
Or by 3. Or by 4. Okay. If it differs by 1, it's a slant asymptote.
So
If it differs by 2, it's a quadratic asymptote.
So
If it differs by 3, it's a cubic
if it
asymptote.
differs by 1, there's going to be a slant asymptote right away.
Bingo. Yes, sir.
Does it matter, like, where it differs by 1? Like, if the top is 2 or if the bottom is 2? The top is 1.
Top has to be bigger than the bottom
Okay.
in order for it to be a slant. Because if bottom is bigger, it's y equals 0.
Oh, right.
Yep. F of 0 then is going to be 0 cubed minus 9 times 0 all over 0 squared minus 4. That's 0 over negative 4, which is 0. So I get a y-intercept of 0, comma, 0. Yes? Yes. X times x minus 3 times x plus 3, my numerator. I'm going to use this one right here because it's already factored. If I use this one way up here, this one, I'd have to refactor it. I already did that. Hey, glad to see you didn't bleed out. Okay? Where did you go? You weren't in there. I went in there. I went to see if you were okay.
I was in the stall.
Oh, okay. That's why. I didn't go in the stall.
But he was teaching now.
I'm with you. I get you. I don't. I wouldn't mind. I got you. Okay. I'm with you. You don't need to justify it to me, man. Use some of this stuff on your phone and calculator and stuff like that. I already did your desk, but you didn't see it. Okay. So, x equals 0. X minus 3 equals 0. Plus 3 equals 0. So I've got 3 x-intercepts. One of them is the origin. Already have it on there. One of them is positive 3, 0. 3. One of them is negative 3, 0.
So can you catch the vertical asymptote?
Can I touch the vertical
No,
asymptote?
can you catch them?
You think about that for a minute. What do you think? Because if I cross it, it exists there. And vertical asymptotes are where denominators are 0, right?
Yeah, but you can catch the horizontal.
You can cross horizontal, you can cross a slant, you can cross a quadratic, you can cross all that stuff. Can't cross a vertical. Yep. Okay. All right. Do I have a hole?
No.
Do I have a slant asymptote? Yes, I do have a slant asymptote. So I have to do x cubed minus 9x divided by x squared minus 4. Can I use synthetic division to do this?
No.
Why not?
Because you.
It's not linear. The second piece is not linear. So I can't use synthetic division. So I've got to go old school. So that's going to be x cubed plus 0 x squared minus 9x plus 0. Right? So what am I going to multiply by?
X.
Yeah, pick a color first.
Go line green.
Multiply both sides by, or multiply by x. Okay? So then that gives me x cubed minus 4x. What do I do with the signs? Change them. So that gives me negative 5x. Is there any way that I can make x squared become negative 5x? No. So then that's just going to be my remainder, right? Okay. So this then is plus negative 5x over x squared minus 4. Okay. Not a big fan of the line green, just so you know. Okay. Now that I see it, I don't like it.
And then look that grade on that.
I like that. That's not bad. I can handle that color. I can handle that color.
What's that? You missed the X.
I get it, Matt. Hey, caramba, child. Oh, look at that. You can actually see stuff now. Amazing. Amaze balls. Oops, I missed. Okay, then what do? Drop the remainder. Now I'll use line green, because you can see it now. So that leaves me what as my slant asymptote? Y equals x. Not 1, because 1's a number met. Y equals x is the equation of a line that is the slant asymptote. Slant asymptotes, or asymptotes in general, are lines, so we have to give them as equations of lines. Okay? A lot of people yesterday in the formative gave me x plus 1 as the slant asymptote. That's not a line. That's a statement saying, yeah, x plus 1. Awesome. Okay? So how do I graph y equals x plus 1? Or excuse me, y equals x in this case. Y-intercept is 0, slope is 1, so I go up 1 and right 1, or down 1 and left 1.
So what was this slant asymptote?
So there's that.
What was this slant asymptote by the formative?
Y equals x plus 1. Function was x cubed minus 9x all over x squared minus 4. All right, so 3, let's go 4, negative 4, and negative 10. If I put negative 4 in there, negative 4 cubed is negative 64 minus negative 36. That's going to be plus 36. So that's going to be negative 28 over 12, which is negative 2.3 repeating. Oh, by the way, noticed yesterday on the formative also, not a fan of decimal points, ladies and gentlemen, okay? Because you round funky, and you round so that it's not right. Fractions, okay? Put your big boy and big girl pants on, and realize that you can do fractions, okay?
Can you give me like both?
You can give me in the answer fractions, and then somewhere else on the problem you can use your decimals and stuff like that.
Track with
I understand. Okay, but
You want
Yeah.
that answer in
fraction form. Yep. Okay. Negative 10 cubed is negative 1,000 plus 90 is negative 910 divided by 96 gets me down here. So this side is there. Middle section, if I put negative 1 in there, I got negative 1 plus 9 is positive 8. All over 1 minus 4 is negative 3. So that would be negative 2 2/3. If I put in positive 1, I get 1 minus 9 is negative 8 over negative 3, which is positive 2 2/3. So this middle section comes through like that. I have a good inkling on what's going on the other one, but let's just test it out by putting in 4. If I put in 4, I got 64 minus 36 is 28, all over 12. Two and a third. And then let's go with 2, 3, 4, 5, 6, 7, 8. Let's go with 8. 8 cubed is 512 minus 72 is 440, all over 60, which is 7 and a third. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 1 third. There's the graph, right? Asymptotal behavior and end behavior now, if we would have to give it. Whoa. Whoa. Whoa.
But isn't there supposed to be an intercept at 3? Or never?
There's one right there.
I see.
So my end behavior would be as x is going to positive infinity, where is my function going? What one? 0 to the right. Do we agree with 0 to the right? As my function, as I go to the right on my graph, where's my function going? It's going up, right? So that means it's going to positive infinity. And as I go to the left on my graph, where's my function going? Negative infinity. Asymptotal behavior. As x approaches negative 2 from the left, what does my function do? As x approaches negative 2 from the right, what does my function do? Okay, so let's deal with those two first. As I'm approaching from the left, to negative 2, as I'm approaching from the left, it's going to positive infinity. As I'm approaching from the right, it's going to negative infinity. Then I have as x is approaching positive 2 from the left, and as x is approaching positive 2 from the right. So I'm approaching 2 from the left. Where is it going? Positive infinity, and then approaching from the right? Negative.
I get a question.
Mm-hmm.
So if there's a slant asymptote, do you use infinity?
Yep.
Instead of
Yep.
0 plus 0.
Yep. Or horizontal asymptote.
Yeah.
People are still, and I don't know why, because I've been saying it since December, since November. People are still using zeros the entire time. Okay? It's not 0 every single time on your end behavior. It's your horizontal asymptote or it's your slant asymptote.
But then why do you put infinity for this one?
Because it's going to infinity on the slant asymptote.
Okay.
Because it's going up
Yep.
into the right.
So for slant asymptote, I get infinity.
Okay? Go for it. Oh well. So pick it up midway through. Okay. Domain, all real numbers. X can't equal 5. Gives me a vertical asymptote of x equals 5. Top has got a degree of 2. Bottom has got a degree of 1. So that's a none horizontal asymptote case. F of 0 is going to be 0 minus 2 which is negative 2 times 0 plus 2, which is positive 2, so that gives me negative 4, all over 0 minus 5, which is negative 5. So that gives me a y-intercept of 0, comma 4/5. We have to put my vertical on there. 2, 3, 4, 5. There. X minus 2, x plus 2, x equals 2, x equals negative 2, so that gives me x-intercepts at 2, comma 0, and negative 2, comma 0. Okay, I have a hole. Factored out an x plus 5 way back up here. So that means I have a hole. So that's going to be negative 7 times negative 3 all over negative 10. So that's going to be positive 21 all over negative 10. So the whole is at negative 5, comma 21, negative 21 tenths. So that's negative 2.1. 3, 4, 5, 1, 2.1. Oops, not solid, not solid, not solid. I missed. Okay, so there's my hole. I have a slant asymptote because it differs by 1. So that is going to be x squared minus 4 divided by x minus 5. Here now I can use my synthetic 1, 0, negative 4, 1, 5, 5, 25, 21. Drop the remainder. So my slant asymptote here is y equals x plus 5. 3, 4, and 5. Okay. Got a good idea that this one comes through there. Yeah? Okay. Then the right side oh, hey now. Get your game on. Is way up there. Yep. It's like in the 30s. It's a bad example.
May I ask a question? We did other examples earlier in the year. We didn't know that there's a slant asymptote. Do we do any questions for one versus the other one? Like there was like x squared versus x.
We did not.
We did. That's wrong. Okay.
Yep.
For some reason I thought that if you factor one, you're